In this program, you'll learn the operation of K Jetronic, also known as CIS, the continuous injection system for gasoline. This program, brought to you by Bosch, shows how K Jetronic is different from electronic fuel injection and different from diesel fuel injection. Economy and clean air with fewer emission controls. Millions of drivers like that about K Jetronic CIS. Smoothness, reliable starting in any weather, and great drivability. Luxury car drivers like that. Power with precision control of fuel. Race car drivers like that about fuel injection. How does K Jetronic operate? Through these fuel lines and injectors, gasoline flows continuously into each intake port near the valve. This is called port injection. In this demonstration of how airflow controls fuel, all injectors have been removed from the manifold to deliver atomized fuel into these plastic tubes continuously. When the airflow sensor plate is moved, it controls the quantity of fuel delivered. A slight movement of the airflow sensor plate causes a small delivery of fuel. Move the plate more, as if more air, and more fuel is delivered. When you finish this program, you'll understand how K Jetronic meters fuel injection according to air entering the engine, and you'll do a better job of servicing the system. As you know, the intake of air into the manifold is controlled by the throttle plates. Vaporized gasoline must be injected into this air in just the right ratio. This air-fuel ratio, known as lambda 1, delivers good power and fuel economy while helping to hold emissions within tight limits. Lambda 1, 14.7 parts of air to 1 part of gasoline, is the ideal air-fuel ratio, burning all the gas and all the air. Air is much lighter than gasoline, so you can also think of it this way. It takes the weight of all the air in this trunk to burn this tiny amount of gasoline, which must be precisely metered. That's why these parts are built with such precision and are fitted together with such fine tolerances. That's why it's important to have clean fuel always and to keep dirt out of the system. In this program, you'll learn the basics of K Jetronic systems. K Jetronic with an oxygen sensor is covered by another program in this series called Lambda Control. The air intake system is shown in blue. Lighter blue shows reduced manifold pressure, sometimes called manifold vacuum. That's downstream of the throttle. The fuel system operates at several different pressures. These colors will help you learn the different fuel pressures in the system. The electrical system is shown in green. More on that later. First, how does the system measure airflow? To simplify, think about an engine at normal temperature and part throttle. The throttle controls airflow into the engine, but measuring airflow is another thing. On its way to the intake manifold, intake air passes a sensor plate in a funnel. The funnel shape is matched to engine operating conditions, so it is not interchangeable with other car models. As the engine takes in air, the plate rises in the funnel. The more air, the more the plate rises. However, if the engine backfires, the plate moves the other way to let off the pressure. But with the sensor plate operating normally in the funnel to measure airflow, any air drawn in downstream of the sensor plate is false air. It will not be measured, so it will not call for fuel to be injected. False air causes lean mixtures and hard starting. So here's an airflow sensor plate pivoting on an arm, balanced by a counterweight. When airflow moves the sensor plate, it moves a control plunger. Most engines use an updraft system like this. When an updraft plate rises, it lifts the plunger. A downdraft plate moves down with the pivot in the middle. This lifts the plunger, and plunger lift controls fuel flow. Remember, the sensor plate measures airflow and lifts the plunger accordingly. You may stop now for review of airflow sensing.
Follow the fuel supply in the system. Fuel at tank pressure, shown in yellow, is drawn by the electric fuel pump from the tank. Pressurized fuel is delivered through the accumulator and through the filter to the fuel distributor, part of the mixture control unit. Fuel shown in red is at system pressure.
The system pressure regulator, a relief valve, returns fuel to the tank. The system can circulate as much as 30 gallons per hour. The electric fuel pump motor is cooled by fuel. The roller-type pump operates without air, so there is never an explosive mixture in the pump. When the pump is running, pressurized fuel fills part of the accumulator, pushing the diaphragm against the spring. It dampens pressure waves and quiets the system. When the engine is off, spring force helps to maintain system fuel pressure. The K Jetronic filter is important because large quantities of fuel are circulated through close tolerances of the fuel system.
You'll find two kinds of system pressure regulators. In new model fuel distributors, since about 1978, the regulator is larger compared to the older pressure regulators used between 1974 and 1978. You need to know this difference because this will affect servicing. In both kinds, system pressure, shown in red, is set by the spring force against the relief valve plunger and its O-ring seal. The pump delivers more fuel than the engine needs, so the regulator relief valve returns fuel to the tank. Compare the upper picture, relief valve open, to the lower picture, valve closed. When the pump stops, the plunger seals to hold system pressure. Here's the pressure regulator assembly with its O-ring seal. You'll be changing shims if you need to adjust system pressure.
You'll remember the plunger is lifted by the airflow sensor plate as it moves to measure the flow of intake air. How is fuel metered and delivered to the injector? The plunger barrel assembly has one metering slit for each cylinder. As the plunger is lifted in the barrel, this control edge increases the flow of metered fuel through each slit. Small lift of the plunger delivers a small quantity through each slit, one for each cylinder. The more the plunger is lifted, the more fuel is delivered. So plunger lift meters fuel according to airflow, meters fuel through each slit and to all cylinders at the same time. The plunger and barrel are in the center of this fuel distributor. Although it looks something like an ignition distributor, nothing rotates to distribute fuel. Rather, all injectors receive fuel continuously.
All the lower chambers of the differential pressure valves receive fuel at the same pressure. In K Jetronic, without lambda, that's system pressure. System pressure is also delivered to the control plunger. The pressure in each upper chamber is reduced because the springs push down on the diaphragms. The springs, pressing down, cause a constant pressure drop of 1/10 bar at each of the 4 metering slits, one for each cylinder. This means metering can be precise, depending only on plunger lift. The more lift, the more fuel. Each injector receives a continuous flow of fuel from its own differential pressure valve in the fuel distributor. Each injector has its own filter, serving as a strainer. Fuel pressure opens the injector valve pin against the spring force. No electric signals here, no metering here, just continuous injection.
You can hear the chatter as fuel pressure vibrates the open valve pins to atomize the fuel for good vaporization. Injector opening pressure is determined by the spring in each injector. It stays open whenever the fuel distributor is delivering fuel. Delivery stops when pressure drops. The injector closes to keep fuel in the injection lines. You've seen system pressure from the pump to the fuel distributor and injection pressure in continuous flow to each injector. You may stop now for review of the fuel system. You know that fuel flow is metered according to airflow, but sometimes the engine needs a richer mixture. How can fuel metering be changed? K Jetronic controls metering with fuel control pressure force on the plunger, shown in orange. Control pressure force tends to balance airflow force. To operate with these forces, the plunger must move freely in its barrel. No dirt, no fuel gum. What happens when fuel control pressure is reduced? Airflow force can lift the plunger higher. This delivers more fuel through the barrel metering slits. Control pressure changes can add fuel for a richer mixture during warm-up. Also, in some cars, add fuel during full load operation and during turbocharging. For altitude compensation, reduce fuel for the thinner air. To system check the K Jetronic, you'll be measuring control pressure under different conditions. What changes this control pressure on the plunger? The control pressure regulator, also known as the warm-up regulator. Control fuel, shown in orange, flows through a restrictor from system pressure and through the control pressure regulator. Control pressure is changed by modifying how much return fuel, shown in yellow, this regulator returns to the tank. On the engine block, the control pressure regulator can be identified by its 2 fuel lines and its electrical connections. This regulator operates at engine temperature. In a cold regulator, the valve diaphragm is open. When it's cold, the flat bimetal leaf spring bends down to lower the valve diaphragm. This allows greater return flow and decreases control pressure at the fuel distributor. In comparison, when the flat bimetal spring is warm, it bends upward, so the coil spring tends to close the valve diaphragm. With less return flow, control pressure rises. Of course, this bimetal spring is warm when the engine block is warm, but after a cold start, enrichment needs to be cut back in 1 or 2 minutes faster than the engine block warms up. So this electric heating coil allows the valve diaphragm to rise during warm-up. As the bimetal spring is warmed and bends upward, it gradually cuts back fuel enrichment, reducing the return flow. Warm-up needs are different for each car model, so do not interchange regulators. Warm-up needs are determined by cold control pressure specifications. At room temperature, cold control pressure is about 1.5 bar, about 22 psi. The warmer the regulator, the higher the control pressure. When the engine starts, the electric coil begins to heat the bimetal spring. The coil is energized whenever the engine is running. On your spec sheet, you can see the warm control pressure, in this case 3.4 to 3.8 bar. That pressure is reached when the bimetal spring has fully raised the valve diaphragm in the control pressure regulator. Increasing control pressure force pushes down on the plunger. On some engines, control pressure force can also be affected by a control pressure regulator which provides full load enrichment as at full throttle. You can recognize this type by the vacuum hose connection from the intake manifold. At part load, manifold pressure, shown in light blue, is less than atmospheric pressure in the lower chamber. This raises the upper diaphragm, reducing return flow.
But manifold pressure increases at full load, increases with turbocharging too. With greater manifold pressure, the inner spring opens the valve diaphragm. This lowers fuel control pressure and enriches the mixture. On units with altitude compensation, an aneroid is used in place of the lower diaphragm to lean the mixture at altitude.
The return line contains a push valve in the system pressure regulator in newer fuel distributors. When the engine is running, the push valve on the right is pushed open by the main plunger. When the engine is off, as in the lower picture, the push valve can close the return line from the control pressure regulator. And so you've seen the fuel pressures, how the control pressure regulator changes control pressure according to temperatures and manifold pressures, how the system pressure regulator sets system pressure and, with a push valve, maintains control pressure after shutdown. You may stop now for review of the control pressure regulator. When the engine temperature gauge shows cold, starting calls for added fuel. It also calls for extra air. K Jetronic does not meet this challenge with a choke, but rather with two starting aids. The first starting aid is the cold start injector, which sprays fuel into the manifold here for all cylinders. This injector is electrically operated. It's different from the continuous injectors at the intake ports. This solenoid injector is connected to the key in its start position. This injector is supplied with fuel at system pressure whenever the fuel pump is running. When the engine is cold, the thermotime switch in the block grounds the injector so it delivers fuel. But if the engine is cranked too long, the system prevents flooding. Here's how. In the thermotime switch, an electric heater warms a bimetal switch to open the circuit. Depending on block temperature, this shuts off the cold start injector after a few seconds of cold cranking.
This injector can also be grounded during cranking by a hot start pulse relay. The relay grounds this injector intermittently, so it sprays fuel in pulses to improve hot starting.
For good starting, it's important the injector open when it should open. But for good running of a warm engine, the injector should be closed. No spray, no drip. The second starting aid, the auxiliary air valve, may be controlled by electric heating or by coolant heating. It delivers extra air to increase cold engine RPM. Through this valve, auxiliary air bypasses the closed throttle plate. When the engine is cold, the auxiliary air valve is held open by a bimetal control. In this type, an electric heater closes this air valve in about 8 minutes, depending on engine temperature at startup. In some engines, heat may be supplied by coolant. For warm-up from cold starts, this air valve must be open, and it must be closed when the engine is warm. You may stop now for review of systems for start and warm-up. As you've seen, the electrical system supplies power to heaters in the auxiliary air device, in the control pressure regulator, and in the thermotime switch, as well as power to the cold start injector and the fuel pump. The fuel pump relay operates with a signal from the distributor in most models. It cuts fuel pump power when the engine is not running, except during cranking. During testing, you'll bypass this relay to develop fuel pressure. Other models have different safety circuits. Understanding K Jetronic will help you to service the system. For example, you may adjust idle speed near the throttle body. This is a warm engine adjustment. This idle speed screw controls the airflow around the closed throttle at idle. This should be one of your final adjustments after checking the fuel control system. In the engine compartment, you'll find specifications for adjusting idle speed and for adjusting CO. The mixture control screw adjusts the position of the control plunger in relation to the airflow sensor plate. Normally, this changes the CO and the oxygen content of the exhaust coming from the engine. You can see how this tool prevents the arm of the airflow sensor plate from moving freely, so be sure to remove it before taking diagnostic readings. That's the basic story of K Jetronic without lambda control. In this program, you have seen how the K Jetronic air intake system measures airflow, how it adds auxiliary air when cold. You've seen adjustments for idle speed and for mixture. How movement of the airflow sensor plate lifts the fuel control plunger. How the plunger lifts in the barrel to meter more fuel to all injectors. You've seen how the fuel system circulates fuel with the electric pump and regulates system pressure with a relief valve. How the control pressure regulator reduces control pressure according to temperature and on some engines according to full load manifold pressure or turbocharging. How changing control pressure force on the plunger operates to change the metering of fuel. You know the fuel system. The differences between system pressure, shown in red, control pressure, shown in orange, and injector opening pressure, shown in pink. Supply and return fuel is shown in yellow. You know all three systems of K Jetronic, including the electrical system for the cold start injector and thermotime switch, and through the relay, the fuel pump and the heaters. You have a better understanding of K Jetronic, the continuous injection system. Brought to you by Bosch.